to talk a bit about what happened. Thanks. What happened during the last year of development, what kind of ideas we had and what we did and kind of what the challenges are. So this is really an opportunity for everyone to maybe help us out, because you realize, oh, I can do this thing. So this is really like a call for help. So let me find the slide that I had. This one here. So I just made this ridiculous looking slide. Yeah. Oh, this one here. So so this might seem weird at first. So what have we been doing last year? And I just want to kind of point out the challenge in building a toolbox that kind of has this size. It's actually quite difficult. So ongoing issues that we have are stability in the sense that things work, then automation in the sense that things keep on working once they work once, usability in the sense that you can actually install this thing. Another thing we had, I mentioned this earlier, is to push the use of this toolbox in educational purposes at universities. I'm going to talk a bit about this. And then here's a nice typo. Should be growth. So we want to grow, and like sorry about this. So the best way to grow is currently through this Google Summer of Code. So we're going to introduce the projects we did this year to you guys. So maybe you're interested in getting involved within the Summer of Code, because it's kind of a limited commitment. And some people in this room kind of got involved this way, including me, Fernando, MT, Dino. Yeah, that's it for here. Okay, so this is going to be a bit more geeky in the way that I'm going to show you a few things. So I first mentioned stability, and I've talked about all the different languages that Shogun interfaces with, right? So we can use it from Python and Octave and Java, and you can use it on a Mac, or you can use it on the Windows, and you can do all these things. But actually, the combinations of possibilities of what you can do kind of explode once you start offering this, right? And it's super hard to keep track of it. So here's one thing that we kind of started. We already had this before, but we really focused on getting this going. And this is an amazing thing. It's called our BuildBot farm. And anyone doing serious software engineering knows about these kind of things. But so I didn't know before I joined Shogun. So what you see here is on the y-axis, you see commits, so changes to Shogun that have happened, in the time. I scrolled out here a bit, but this is like, through maybe one day or something. And on the x-axis, you see different computers essentially building Shogun and running all the tests we have. So I can zoom in, I can show you what's going on here. So this one, just going to show a few examples. So this one here is a Fedora build, like on the Fedora Linux operating system. We're building Shogun and testing everything. Here's a Windows build, here's a Debian build, then we have Ubuntu, we have Mac, it's in the back. And these things kind of make sure that everything works under each platform. So this is a thing that we're putting lots of attention in, and we need people that know about this stuff to help us out to making things stable. Because now I can tell you, well, all the green things, it works. So if somebody comes to me and it tells me I want to use it on the Mac, does it work? I say, well, yeah, it works, and here's our build that definitely works. And we also need to communicate this a bit more to the outside world, saying, yeah, well, this is all the stuff we support. So a great deal of effort has went into this. That might be a bit unexpected if we talked about machine learning all day, but actually this takes a significant amount of our time when we're doing stuff. Any remarks on the BuildBot? No? Okay. So then another thing we started doing is, so we are a project that is about, we're more than 10 years old, and so the code in there is also more than 10 years old. So there are lots of, we basically pile up bugs. That's what we do. And so one thing we also started doing is we're using kind of a static code analysis here that, there are even though it's a hard problem to verify software, some things you can actually detect them. And this thing revealed, a couple of hundred memory bugs that Toralf, for example, then, ended up fixing loads of them. So that's amazing. That's kind of a good way to improve the quality and the stability of the software. Because like 3 years ago when I joined the project, what happened often is that you install it and you go through the process and the pain of installing it, and then you try to run it and then it just crashes. So, and this is kind of a thing that happens all the time. And actually in academia, whenever people start developing software, things usually don't scale up. At some site they just stop working. So this is our way to, so we managed to survive this. The project didn't die because of scalability issues. And this is another thing we do towards this. So if you're interested in this kind of stuff, it's not about machine learning, it's about computer programming, but get back to us. Super, super important. Here we kind of, we have this list of, resource leak, out of bounds read in arrays and these kind of things. So it's quite nice to be able to detect this. And also so everything that now is implemented into Shogun, and this is also interesting for scientists, is properly tested. So whenever a new algorithm is put into the toolbox, we put a kind of a great deal of effort into testing them, but then also making these tests sustainable in a sense that we can test this at any time. And this buildbot thing I showed you earlier runs all these tests. So when somebody comes along and implements a new variational inference algorithm, if you just do this kind of in a collection of MATLAB scripts, and then people, over the years start modifying them, then things that worked initially might break in the meantime. We have a way to prevent this, so this way we really hope that we are sustainable in a sense. So it's a sustainable project, and it's good to put some belief into this, right? This is very important. And we had massive issues with this, and we solved them during the past year. Okay, that was stability. Now, usability. So last year at the workshop here, we first came across these IPython notebooks here, and we really like them because it's kind of a nice way on our website to expose them, and then you just have a list of these notebooks and you can just click on them and you can see Shogun code and you can see examples and you kind of get a little tutorial. So we thought, it would actually be cool to do this in an interactive way. So what we did, and this is just preliminary, but we plan to extend this, is we set up a web service where you can use the toolbox just from your web browser without having to install anything. So you just launch your web browser, you type in this address here on the top, then you have to log in with some Google or GitHub details. I just did this, and then you get a list of notebooks. And in particular, you get to such a notebook server here. And this thing runs, let me zoom out a bit. This thing now doesn't run on my computer anymore, it runs in the cloud, and you can choose any of those notebooks or you can create a new one. So, for example, here I created a little notebook and I wanted to do a little, little demo that you can actually use this stuff for computing. So, there's a notebook and I just create some random data. I just will do some toy stuff. So let's just create some Gaussian kernel. So this works, and then so you can do something like this. Let's hope it works. There's sometimes some delay because our server is busy. It worked 10 minutes ago. It's ridiculous. Let's try again. Yeah, it doesn't work. Something is weird with the computer, so shift enter. Well, okay, I'm going to skip this one, but actually in principle this works. I just tried it ago. I don't know what's going on. I mean, maybe it's because too many tabs are open. But you can run the Shogun code from here. And here are some notebooks that I ran. So these are notebooks from our website. Let me maximize this. So this is a notebook about ICA, for example. So ICA is another, it's a standard method in machine learning to separate sources. You have like a couple of people talking in a room, you put up a bunch of microphones, you record them, and then you want to kind of identify the independent source in the room, so kind of identify the individual speakers. So, well, you say, well, that sounds nice. Let's look at the Shogun implementation of this. And here you have an interactive way that is running in the cloud, where you can play around with these things, and you get like a nice introduction. You get a little, I ran this earlier, so this ran in the cloud. You can, we kind of guide you. We set up some sounds actually, and I'm going to play this. So the guy here, he loads some sounds, and then he mixes them by hand. And plots the sounds. These are the sounds.
Good day, Commander.
So you got these, a bit nerdy. So you got this sound. Come on.
You have it in the computer, right?
So,
Good day, Commander.
so we had this one. Okay, let's play this one. Come on. Don't know. This is some. Okay. So we got these sounds. So this is how we do all this. We mix these sounds. Mixing is a linear operation, so we just define some matrix for 3 sounds, and we just mix them. We all do this in Python, and then the things look like this. So you heard the mixture, right? So we have all these mixed sounds now. Another one. Okay. So now you might ask yourself, okay, how do you do things? So then in the notebook, you just logged in. It's just 1 minute ago. You just load the stuff, and us in all the previous notebooks, we then convert our mixed signals into Shogun format. Then we have them here, and then we do some ICA method here called JADE, and we talk a bit about how it works, and then we just apply the stuff, and we get the decorrelated signals, and then this is what the algorithm outputs in the end. I don't know what this is. So So we have done some nice machine learning. We have separated sounds, and this all worked in the cloud. So this is kind of nice. You can try out Shogun without installing it. And we want to push this a bit further, because currently this is an old version, but we kind of want to automate the process of having this. And then this might be useful if you teach courses at universities. This might be useful if you just quickly want to try out like a little concept that is maybe not too computationally expensive, whether a certain algorithm idea works, or you would just want to, play around with stuff. This is quite nice. And then once you're curious, you can install the whole thing. Yes?
So how does storage work when you run things?
So it works is we have this server, and we run it somewhere, and this IPython thing is like a separate process that's running on there, and every time you log in as a user, it kind of creates a new fake user in this operating system. And you get your own home folder, and that's stored in the file system. So if I modify this work is saved for later. Which is kind of nice. So you can also like save things and then continue working later. We currently have a time restriction. You can only use it for 1 hour and then you're kicked out. And also if you start doing super intense computations, we also kick you out. So as I mentioned earlier, we're kind of trying to look for sponsors. So it might be cool if some company gives us some computation power, and then we can put this service on there, and then this kind of nice stories to tell about this. Okay, this also is very tightly connected to this education thing that I mentioned earlier, right? Usability. Okay, cool. Let me close this one. This one also close it. Okay, then speaking more about visualizing things and stuff. So we also last year we had a nice project where a student implemented a web framework where we can run Shogun in interactive JavaScript applets in the web browser, which is also kind of cool. So I'm just going to show you one example here and hope that it works. Let's do this one here. I think I already. So this is OCR. I think I had an example on this earlier. So you can do things like this, and then you can press a button here. And then we got a multi-class support vector machine running in the background. It was trained on the USPS dataset or some similar stuff. We crop the image, we apply this algorithm here. There's like a particular SVM solver, and we get a proper prediction. And then you can play around with these things. I think this is super nice for see what this is. It's a bit hard without the proper mouse. So wait, let's do a classical one. This should be good. Yeah. Let's do this. Yeah. Okay. This is just playing around. But now imagine you are professor for some machine learning thing, and then you wanna talk about SVMs, and then you tell people, well, you should use kernels for your SVMs, and then we also have a little applet for this. So is it this one here? So and then you kind of want to say, okay, well, let's I wish I could use a mouse. So you say them, okay, well, here you have some data, you can put up together some binary data, and then you can, train let's hope this works. Yeah, you can train a linear SVM, and you kind of get this decision boundary runs here, and then you can say them, look, this is bad, we obviously want something more nice, and then you can change the kernel.
This button called classify the train.
Because it classifies every point in the grid here. So we plug in a Gaussian kernel, and then we get something like this, right? So that's kind of neat. If and this is fairly flexible. These are just some very stupid examples, but now, if somebody would be interested in, say, coding up a proper deep learning example for this one, with visualizing neurons that are kind of doing stuff, visualizing algorithms, you can do all this in here, because you can, this is all written in Python, and you can access Shogun in the normal way from this. So you can basically do whatever you like. So it's kind of cool. Also, if you're a scientist and you just wrote a paper on, variation inference or to sample testing, and you kind of want to visualize how, for talks, how does this work, and then you have an interactive applet for this. It's kind of cute, I think. Okay, let's close this.
How easy or hard is to write these things? How do you proceed?
I can. So the source code is online. We have it's on our GitHub webpage. You can just. Yeah, it's all written in Python, and there's a whole framework that's already sitting there. So currently, I have a student that extends this. He just extended the GP thing. Actually, I have this here.
So the student made the
So this didn't exist 1 month ago, and he just wrote it, and you just have.
So it means that it takes considerable effort to be able to put this thing. If let's say I want to code it myself.
Oh, you can do this if you want to.
I think you should, if you want this to be for education, you should open it to teachers, and they can make the library, and then it becomes usable.
Yeah, exactly. Yeah, we should open this up for other people to use it. I agree. We just need somebody has to do it. That's always the problem. So I really like this one. You can also here plot the predictive distribution. This kind of cool for GPs.
Almost everybody is actually trying to do this kind of stuff, right?
Yeah, exactly.
What do you mean with open? Sorry? What do you mean with open? It's open source.
Well, I mean that let's say I'm going to teach next term, and I want to be able to teach some concepts to my students. You have already all the methods built in. I want to make a demo that suits what I want to say. This should be, if it is customizable like that, or if it is with your input, with somebody's help, if you could do that, then it'll be great, because they'll make all these demos and they'll put it online for everybody to use. And Shogun gets richer, there's more resources for other people to use.
I think that's a great idea. I think what would be maybe a nice one to do is to start with some little building blocks that everyone can use, and then you for example for SVMs, because that's such a standard topic, or GPs, and then you kind of give this to somebody and just see what happens. Yeah.
A really cool thing I think that needs to be done especially for teaching. I was reading Gelman's book on this. If you have read Bag of Tricks for Teaching Statistics.
Yeah.
It's amazing how he has written all these exercises that you could do. And for computer science, I think this is what we need. We need code that that runs very easily. Students can change small things, and we need to back tricks for teachers.
I agree. Yeah, that's exactly the point. That's why we're doing this. Okay, let's press on and speed up maybe a bit. So yeah, we had so yes, this is our website. So have a look, go home and have a look on the notebooks that we have. They're super cool. Some of them are actually quite sophisticated, and I don't even understand all of them properly because there's, modern stuff is going on. So I mentioned this guy who's just building these web demos here. He does a project, we call it Missionary, like telling the world how good Shogun is. And he also started doing things that might be useful for teaching. He started writing notebooks just about, very principle, very low level, what is machine learning about, kind of a tutorial for people. I don't know if you know these things. There are books in the web called Machine Learning for Hackers or Statistics for Hackers, where you kind of, get a hands-on approach to these problems, and you kind of can do things yourself and you can modify them. And what's cool about these notebooks is, he kind of starts with, okay, let's talk about supervised learning. Here's how you load data sets from a file. Here's, different feature representations and all of this. But the cool thing is then you can always press this button and get this interactively, and then you can modify things. So it's quite cool.
So there's some recent stuff that I saw on the web. People are trying to convert these books to Python. So somebody's writing machine learning for hackers using Python. He's just changing all the code that's in order.
Oh yeah.
So I think that also might be a good idea of people have done before.
Yeah.
Incorporate all that. And the nice thing here is that you could put R code and you could put Python code and put other things together.
Exactly. It would.
That you got.
Yeah. Very good. That's if you wanna, we should push this. We should get some people into doing this because it's it still takes time, unfortunately. Okay, that's this. Okay, then finally, so Shogun is actually in Debian. And we wanna. So one problem is it's horribly painful to install the thing. And people who have been yesterday at our hands-on session, we actually spent half of the day guiding people how to install it because we're written in C. It has to be compiled. There are hundreds of external dependencies. People have Macs. People have Windows machines, and everyone just says, "Yeah, well," but we kind of tell them, "Well, if you use a more sophisticated operating system, then things are easier." But we can't tell people to do this because people just want to do what they want to do. So our plan is to release binary packages of Shogun so that you can just one click install the thing. And we need help with this. So if you know anyone who is into these kind of things, anyone who is into operating systems and stuff, let us know. So Søren, the main guy of Shogun who started the project, he's in Debian. That's kind of the main Linux distribution. So we have packages in there, which is super nice because it also means they pass quite a few tests. And then Björn, is Björn here? No, he's outside. He made it happen that Shogun is now in Fedora. And if you know somebody who uses a Mac and can do these kind of things, maybe get him involved with us because this is very hard to do. But this is definitely what we need to do next and what we have been focusing quite a bit recently to make this easier. Yeah. And then the last point in my slides, future plans, was Entschlackung. It's a German word and means that we should get rid of some things. Just gonna show you one little example of a thing that I found not so long ago. So I was going, this class here was buggy, so I was going through the code. It's okay, this all looks good. This is some kind of biologically motivated similarity measures between amino acids, I think, and then I found this. It's okay, it's nice, okay. So we can for every line of code we can see who committed this. But then we have lots of things like this in the code base, and it's a constant effort of getting rid of these kind of things and making sure nobody puts them in. Yeah, this is what another thing we want to do. So to make the thing a bit more slim and stuff. But this is just to give you an idea of the daily life of doing open source machine learning software. Yeah. So the plans for the future is go in these directions, have binary packages, make everything easier, and push this education thing, really. Okay, cool. And now finally, we have a little feature about the Google Summer of Code that everyone mentioned so far. Fernando prepared some slides for this. So here they are. So this is really the main motor behind this project. And so Google runs this program. What they do is they say, okay, talented computer science students in the US traditionally have summer jobs. They go to a burger place and flip the burgers, and then Google came with the idea, maybe they should do something that they know how to do. So the motto of the thing is flip bits, not burgers. It's kind of a nice one. So it started 10 years ago, so this year's the 10th time, 2004 was the first one. So the way it works is like this. A bunch of open source projects apply to Google and say, we want to participate in your program. Google selects a couple of these projects, and this depends mainly on the quality of an application that we write. So it's quite a bit of overhead. I spent like 1 week on this, just writing here. We have lots of infrastructure. We have an active community. We have mentors. We have fail-safe mentors. We did it successfully in the past. The stuff we do is important for other people. So you have to, it's almost like writing a grant application. Then Google releases a list of accepted projects. And then the projects, so in this case we come up with a number of project descriptions for student projects, right? Like implement a particular algorithm, implement this web demo framework, build a binary packaging system. And we have like a little description with this and a mentor, and we kind of internally synchronize. And then students can apply to us, to these projects. And then what we do is we rank the students, and based on the number of applications we get a number of slots from Google, like a number of students we can take, and we usually get 8. And then we notify these 8 people, and then they work during the summer, from May till August, they work full-time on this, and they receive a stipend of $5,000. So it's quite nice, right? Because there's a lot of momentum going on when you work full-time. For the students, it's great because they get lots of money, especially if you live like in Mumbai or in, somewhere in the depths of Russia. Then that's kind of cool. Actually, an Indian student told me that he kind of made a living for almost a year from this money, like living with his parents and whatever. And all the work remains open source, so that's cool. All that is get back, kind of we control it. Nothing of this goes back to Google. They just kind of, pay for this to have this. So yeah, I said we had 29 students, so that's 29 times 3 months times $5,000. That's quite impressive numbers. And we have a lot of impact in this, so we got a lot of visibility. We got like 150 applications, which is ridiculous to read for us 5 people, actually. So we have other tricks to filter it using machine learning. No. So currently it's running. So there are currently 8 guys working their asses off. And so 2 of the projects were already mentioned. So one is the one the talk by Dino, doing all these kernel embeddings of distributions and distances between distributions using for sample testing and independence testing. So you already heard about this. And the other one is MT's project and mine. Where a guy implements all of MT's cool algorithms for variational learning. And here's some more. I already mentioned this guy. This is like we realized, we need more documentation. We need to tell the people how cool things are. So this is the Shogun in Education and the missionary project. And the guy basically spends all of his time writing notebooks about linear regression and how you use Shogun, basic things. Nice visualizations, like things that are cool, things that we can show to others. He writes these web demos, and he also improves the documentation here and there because he actually uses all these, fundamental things. Then he realizes, it's not documented. It crashes. So that's very, very useful, and we probably will keep on doing something like this. Then here we got a bit, infected by the hype of neural networks. So we thought, let's have a project. And one of the old Shogun people, Gunnar Edge, who is the Gun in Shogun, he he suggested to do this, and he told us, yeah, one of my postdocs works in this, so let's do it. So we now have Boltzmann machines, we have autoencoders, we have convolutional neural networks, all this stuff. We all have all this now. And the guy who's doing it is quite talented. He's also like writing a whole framework for doing linear algebra on a GPU, kind of in a unified way, so that we can, that kind of, at compile time you can choose what's the back end of your computation. So with just one button while you're compiling Shogun, you can change, you do your Cholesky decomposition on one CPU or on multiple CPUs on the graphics card, but the code doesn't change. So that's really cool for us, because we can then generalize all the existing algorithms to run in parallel or to run on GPUs. And we do this kind of for all expensive operations, like a convolution, or like a matrix-matrix multiplication, or a linear solve, or an SVD, things like this. This one here is Fernando's project. Maybe you want to take over now? I can do it from there.
I'm mentoring this guy, Parihat. I'm sorry about it, but I don't know how to pronounce it correctly. And well, the idea is to work on fundamental machine learning algorithms, so algorithms that are really classical, so very old algorithms in some sense that we were actually lacking of, or that we need some improvement. So we didn't have, for instance, decision trees, so he has spent quite a bit, so he has made quite a nice implementations of decision trees, so different types of these ID3, C4, 5, and classification and regression trees, so discard. And also has implemented some, so they are not just really basic implementations, he has also done some extensions like pruning for overfitting, and in the notebooks he has also just not make tests on toy data, but also use some real world data from this UICI databases, so it's nice. And there's a picture in there of doing regression with a decision tree.
It's another buzzword, random forests.
Yeah,
we also have those now.
He has also used these random forests, and also some work that we had of bugging machines in Shogun to build up random forests. And then he has made, he is actually quite active, so he is making a lot of stuff. He has implemented KD trees and bolt trees, so we can do more efficient K nearest neighbors with that, and also he has used these trees to make an efficient implementation of kernel density estimation. Yeah, that's pretty much part, yeah. Then Kislai is being mentored by Kevin, who is a guy that is in Canada, and he's working on integration with OpenCV and Shogun. So basically he started with doing some factory classes to communicate so that Shogun and OpenCV can talk. So some OpenCV, this CV mat data structure is quite fundamental there. So now we have some methods that you can just, your data can flow really easily from the matrix that we have in Shogun and these matrices that you have in OpenCV. And then he's just, so this is computer vision, so this is quite fancy to see pictures and this kind of eye candy. So he's working on notebooks and other like visual output demos. So he has done something on feature faces, and these pictures in here are from a notebook in automatic number plate recognition. So here he's using OpenCV for all this detection where in the image the number plate is, and then he's using Shogun for making this OCR and detect the actual numbers and letters in the plate.
And we think this is super cool because OpenCV is a standard both in industry and in academia, and but it doesn't really contain like proper machine learning algorithms. There are a few things in there, but it's mostly about really image processing and doing stuff on this. So we can just take these pictures, we can detect the features, and then we can straight away feed them into our convolutional neural net implementation too. And he's currently working on one of these deep learning benchmarks using OpenCV and Shogun together, which is very nice. And also OpenCV has lots of really efficient implementations of like filters on images and stuff like that. So it's quite cool.
I think this is one place where you could put a lot of visualization, like for educational.
Yeah, exactly.
It's love to see you.
Yeah, so have a look on our website. The notebook will appear there like next week. that kind of does this full thing, kind of recognizing. We get like digital output of all the numbers on the plate, which is cool. So let's draw off.
Well, this project deals with multi-label classification. This is new to Shogun because currently we only have binary or multi-class classification, which allows predicting exactly one output, while multi-label classification allows us to predict multiple outputs. And well, if you allow multiple outputs to be predicted, then you want to have problems where you have about 8,000 or 1 million output labels, and in this case, when we use the structured output framework, it will explode immediately because the joint feature vector will just be very big. And the student is just implementing, has been implementing this in Shogun using the structured output framework. He has implemented hashed and non-hashed variants to reduce the number of dimensions we have to deal with, and he has also extended this to the hierarchical multi-label classification. That means predicting taxonomies with predicting taxonomies or multi-labels from taxonomies for given documents. And while doing this, he also greatly improved the performance of the computational performance of the structured output framework, because well, if you want to try to predict so many labels, then we have to do some optimizations, and that's what we did in this project, or what we currently are doing in this project. The next student is also extending the approximate inference, the structured output framework. He adds approximate inference to the framework for doing the decoding of large vector graphs, and he implements the graph cuts and the message passing LP relaxation and the tree max product. Okay, actually the tree max product is exact inference, but it's kind of a baseline for the other methods. And he was also extending the Shogun interface to the Mosaic solver because we had to introduce some additional constraints to make the optimization problems to ensure the submodularity conditions in the optimization problem. So yeah, this was kind of a lot of work, and we now have great things to scale more because we don't have to solve it exactly anymore.
Okay, so this makes 8. These are our 8 projects. The same thing will start next year. We'll probably do it again, and we'll probably get again 8 slots. So if you have any ideas for new things that could be implemented, and you either want to mentor them or you want to participate as a student, just let us know, because this is super fun. And yeah, with this, actually, the workshop is, we close now. So currently Søren is currently setting up a barbecue outside. So feel free to stay a bit with us, have a chat, have a beer and all this. And so yeah, I guess we should thank the Seabase a lot, especially Riot, the guy back there. He kind of helped us massively in organizing all this. So really appreciated this thing. And then finally, so the people from the Shogun team who organized this, also Toralf put in a lot of work for this. Fernando just came here to organize the thing. Björn is also around. So this is really also cool. It's really nice to work in this team. So thanks also to you guys. And then with this, let's close.
Well,
thanks.
Thanks to Heiko.